It's Monday the 30th of December. My name's Juan Brown. You're watching the Blanco Lirio channel, and a lot of folks are looking for answers to what happened to the Piper Cheyenne 2 aircraft that went down in Louisiana on the 28th of December. Unfortunately, it's going to take 12 to 18 months before we get any solid answers after a thorough investigation by the NTSB as to what happened to this aircraft. Why is it going to take so long to figure this out? Because this aircraft was not required to have any flight data recorders on board this aircraft, so the NTSB is going to have to, as they say, go old school in this investigation and just look at the wreckage itself and try to piece together the puzzle as to what happened to this aircraft without the assistance of any data recorders on the aircraft. This flight was apparently operated under FAR Part 91. FAR Part 91 is what general aviation operators, like when I fly the Luscombe, operate under. This allows us the freedom to operate these aircraft without all of the requirements, additional requirements, safety requirements found in Part 135 charter operations or Part 121 airliner type operations. One of the freedoms that Part 91 gives us is relief from the requirement to carry expensive data recorders on board the airplane. So all we can really discuss at this time is the facts as we know them. We could discuss the weather a little bit and a little bit about this particular aircraft. There are some important details about this particular aircraft that investigators will be looking at very closely. The accident happened on 28 December at Lafayette Regional Airport. The flight was en route to Atlanta to fly to observe the Peach Bowl football game. There were 6 people on board, 6 souls on board, 5 fatalities, 1 survivor in critical condition. 3 people on the ground were injured. The aircraft departed runway 22 left at Lafayette Regional Airport. That's the longest runway at the airport, 8,000 feet long. The weather at the time was 3/4 mile visibility with a cloud base at 200 feet. That's IFR weather, instrument flight rules applied for this flight. The aircraft departed 22 left, climbed up to about 900 feet, and fairly quickly after takeoff began a left-hand turn, accomplishing about 90 degrees of heading change, and descended from 900 feet to impact, all within 1 minute after departure, after takeoff. As the aircraft descended out of 900 feet, at 700 feet, the air traffic controller or the tower controller alerted the pilot, gave him a low altitude alert warning. There was no response from the pilot. There was no distress calls at all from the pilot. This was a single pilot operation. Here's the Flight Radar 24 plot based on 4 ADS-B data points showing the altitude in blue and a steady speed in yellow. The NTSB is on the scene and gave a briefing yesterday. Bruce Landsberg gave the briefing. The NTSB does have 2 videos of the crash, and they have 2 witness reports. One witness stating that they observed the aircraft in a steep left bank turn, then level, before impacting power lines and the trees. Bruce said he walked through the wreckage area. It was about 1/4 mile long, and it appeared to him that the aircraft crashed in a straight ahead condition, indicating that the aircraft was moving forward. It did not spin in. The min-altitude alert that came from the air traffic controllers is a forward-looking system using the transponder information from the aircraft. The radar display screen will alert the air traffic control operator that the aircraft is about to descend below the minimum safe altitude for the location where the aircraft is flying. That allows time for the controller to get that information to the pilot before he actually descends below the minimum safe altitude. No response was heard from the pilot. The single pilot has a commercial rating, and that's all we know about him so far. The weather IFR at the time. This is an extremely high workload environment, especially for a single pilot. In fact, it is the most demanding workload environment. A high-performance turboprop twin in IFR conditions with a fairly full load of fuel and people. When the weather's down to 3/4 mile visibility, you climb up into that overcast at 200 feet, it's like flying inside of a ping pong ball. You can see, the 3/4 of a mile, but you can't see much, you can't see anything. It's just a white ping pong ball of moisture around you. You're relying on the instruments as a single pilot without having a co-pilot backing you up. And in this case, probably did not have an autopilot engaged this early into the flight profile. This is an extremely demanding flying environment and has little room for error and even less room if anything goes wrong. Because of the limitations of the design of the human inner ear, as we were not designed to fly, once we lose sight of the ground in an airplane, we have no way of telling which way is up other than the instruments. This can very quickly lead to spatial disorientation and is a very common cause of aircraft accidents when operating in IMC or instrument meteorological conditions when you cannot see the ground. The NTSB will be doing their usual investigation on this accident. First, they're going to look at the wreckage and locate what they call all four corners of the aircraft, the nose, the two wingtips, and the tail, make sure all the wreckage is there in the debris field and that there was nothing that came off of the aircraft prior to impact. They'll be able to take a look at the engines, and by looking at the engines and propellers, they'll be able to determine if those engines were making power and the correct amount of power at the time of impact. Witness report seems to indicate that both engines were screaming, as one witness testified or has said so far. Investigators will be able to look at the control linkage, what's left of it, and that's the problem. All this wreckage is highly damaged, burned, and charred, and so it's going to be a real challenge for investigators to put this puzzle back together, but try to attempt to see if all the flight controls are intact. Investigators will be closely looking at the pilot's record of training, his entire flying history, his last 72-hour history they'll be looking at very closely. And then, of course, the weather, which we already know is 3/4 mile visibility and 200-foot ceilings. Not the best weather for flying. However, legal to fly under Part 91. Now let's talk a little bit about this aircraft, and one very important point that the NTSB will be looking at very closely on this particular make and model of aircraft. The Piper Cheyenne aircraft is a development of the Piper Navajo series of aircraft. The Piper Navajo series of aircraft are a light twin recip powered light twin. The Navajo then became a pressurized light twin. These were with two Lycoming engines. And then the design got stretched even further and became powered by the standby. And then the design got stretched a bit further and repowered by the Pratt & Whitney PT-6A turboprop engines. With the turboprop engines, the designation became the 31-T model, and then the 31-T2 or Cheyenne 2, which this model is. The Cheyenne 2 aircraft has 6 passenger seats and 2 pilot seats for a total of 8 seats on board. Once that aircraft was designed to that extent, a new system was installed called the Stability Augmentation System. Now, if this all sounds very familiar in our discussions with the Boeing 737 MAX program, it is. And this is a problem where folks are not understanding about the 737 MAX. The stability augmentation system in the Piper Cheyenne II uses an angle of attack vane, a computer, and servos to add additional feel to the yoke under conditions of high angle of attack and aft CG. Designers found that the Piper Cheyenne II aircraft, in these configurations, high AOA, aft CG, the stick forces were excessively light. Remember our discussions in previous videos. Aircraft need, in order to meet FAA design requirement specifications for construction, they need to possess a certain amount of stick force feedback. As you get closer to stalling the aircraft, you need to feel that stick force in your hand. The stick has to have a certain amount of force, and that force changes with airspeed. In the case of the Piper Cheyenne II, with an aft CG loading, the stick forces become too light, and it becomes very easy for the pilot to over-control the aircraft in that situation. So the augmentation system, stability augmentation system, feeds in a little forward elevator trim, if you will, not quite like the Boeing 737 MAX, but very similar, to add just a little bit of down force to the stick, a little bit of resistance to the up force, up that you're trying to add to the stick, or the yoke in the case of the Piper, to prevent you from stalling the aircraft, to remind you that you're getting close to stalling the aircraft and you need to decrease your angle of attack. This is not to be confused with a stick pusher or a stick shaker. This is not an automatic stall recovery system. That's the pilot's job. In the case of the Piper Cheyenne II, the stability augmentation system, if it fails, it will give you an alert and a light, and you can override the stability augmentation system through a kind of monkey motion pulling of a lever on the instrument panel. Once you access the panel to get to the lever, investigators will be needing to look at this closely. They'll be, if they can, they need to find the components, the mechanical components to the stability augmentation system, to see if the override system was actuated or not, or if they'll even be able to determine that, because the wreckage may be so great that either that evidence is destroyed or the stability augmentation actuator may already be in the deployed position because of the impact, not because of pilot input. It's going to be hard to tell. But investigators need to focus, or they need to look at the stability augmentation system to see if it was a part or a factor in this accident. If the pilot manually overrides the stability augmentation system in the Piper Cheyenne II, all it does is apply maximum spring pressure to the system to give you a little bit of forward elevator trim, and help to prevent the pilot from over-controlling the aircraft in pitch in conditions of high angle of attack and aft CG loading. Other models of the Piper Cheyenne did not include the stability augmentation system. Subsequent models of the Cheyenne were extended forward of the main spar instead of aft of the main spar. So by extending the design forward, they were able to get away from aft CG loading problems that were found on the Cheyenne II series of aircraft. Also, too, these aircraft come with a load plotter, kind of a plastic device that helps the pilot carefully plot the loading of the aircraft, and make sure, the bottom line is, get your heavier passengers loaded more closer to the front of the aircraft. So investigators will be looking at closely at the loading of the aircraft. They got to try and figure out where everybody was sitting on board the aircraft if they can. It's going to be 12 to 18 months before we get any real answers as to what happened to this aircraft. There's a couple of prior history accident reports that read very similar to this particular accident, but On each accident investigation, investigators want to start with a clean sheet of paper and not start with any bias preloaded into their investigation. As we get more information, we'll post it here. See you here.